Okay, we're going to do practice B. This is chapter 14. And today we're going to do the lenses. Now we already just talked about how the equations for mirrors are the same. 1 over f is equal to 1 over di plus 1 over do. And then that the magnification is hi over ho, which is negative di over do. So first let's look at number 2. So number 2 says Sherlock Holmes examines a clue by holding his magnifying glass at arm's length and 10 centimeters away from the object. So we're given that the distance of the object is 10 centimeters. The magnifying glass has a focal length of 15, so f is equal to 15 centimeters. Find the image distance. So I want to find di and the magnification m. Describe the image he observes. Okay, so first I want to find di. So our basic equation is 1 over f is equal to 1 over di plus 1 over do. Now on the FRQ part of the test, you need to write the basic equation in this form if you want to get the credit on the rubrics for the equation. Okay, don't just start writing numbers. Don't rearrange it because you can make an algebra mistake. On the last test, some of you still refuse to do what I showed you where you rearrange the equation to solve for the unknown in terms of the known. And then on some of the tests, and I don't remember off the top of my head, but you can't just add or subtract denominators or fractions. So I was kind of a little surprised. Now, I'm not going to spend today rearranging the equation because we've already done that. So di is equal to dof over do minus f. When you put it in this form, your unknown in terms of your known, it's easier to put in your calculator. You're less likely to make an algebra mistake. You're less likely to make any type of mistake. So now we have 10 times 15 over 10 minus 15. So 10 times 15 is 150, and this is minus 5. So 150 divided by negative 5 is negative 30 centimeters. I don't even need a calculator. Now, when you're taking a test, don't just press the buttons on the calculator. We all make mistakes. I make mistakes too. So you can do mental math and look at this and see, I didn't use a calculator to do this. I did that in my head because those are numbers that were actually easy enough that I could do it in my head. All right. Part B says find the magnification. So first I'm going to write the equation. Now magnification has two parts. Magnification is hi over ho, but it's also negative di over do. So which part do I know? Which part should I use? Well, I should use the part for what I have. I have do, I just found di. So obviously, I'm not using that part, I'm using this part. So di, so it's equal to negative 30, divided by 10. So a negative and a negative is a positive, and 30 divided by 10 is equal to 3. And then the question said, describe the image that he observes. So if I want to, it's upright, but if I wanted to calculate that, then I could use like hi over ho is equal to negative di over do. Okay. All right, let's go on. Let's do number 3 since it's going to be a little bit different. Okay. Number 3 is a different type of lens, and that's why I want to do this. So it says an object is placed 20 centimeters. So I'm going to write my given. And where the object is placed, that's the distance of the object. So that's going to be 20 centimeters in front of a diverging lens. So diverging lens is the ray of that looks like this, where when the rays of light go through it, they diverge. Diverge means to spread apart. So that's important because the focal length is 10, So that means F is equal to negative 10 centimeters. So this negative sign here is because this is a diverging lens, and the focal length is going to be negative on diverging lenses. So now it says find the image distance, which is DI, and the magnification M. And then it says describe it. So first I'm going to write my equation. The basic equation is 1 over F is 1 over DI plus 1 over DO. Then I'll rearrange the equation to solve for the unknown in terms of the known. So DI is equal to DOF divided by DO minus F. Now I'm going to substitute in my values. So I'm going to have 20 times negative 10 over 20 minus negative 10. So 20 times negative 10 is going to be negative 200. And then 20 plus 10 is going to be 30. So now I can take my calculator and I can say 200 minus divided by 30. And I could probably do this in my head. And I see the answer there that DI is equal to negative 6.67 centimeters. Then part B says find the magnification. So magnification is equal to negative DI over DO. So it's going to be negative 6.67 divided by 20. Oh, I should have left my answer there. So a negative and a negative is a positive. Divided by 20 comes out to be 0.333. So this is 0.333. Remember, magnification has no unit. Now, when they describe this, as we just talked about a few minutes ago, so I'm not going to do a calculation because I know with a diverging lens, my image is always going to be smaller, virtual, and upright. Always. So instead of doing all that, I'll just write that it's virtual and it's upright. As far as the description, because all diverging lenses are going to be virtual and upright, and if I wanted to, I could add the smaller in there too, even though they didn't ask for that. And that's it. So this is pretty easy because we're already used to using these equations. Okay.